Hello friends, welcome to Joy of Life. So today, once again, we are going to look at a hard level problem from Leetcode. The problem number is 297. It's about serialize and deserialize a binary tree. It's a hard problem. So the description says serialization is the process of converting a data structure or object into a sequence of bits so that it can be stored in a file or memory buffer or transmitted across a network connection link to be reconstructed later in the same or another computer environment. Design an algorithm to serialize and deserialize a binary tree. There is no restriction on how your serialization deserialization algorithm should work. You just need to ensure that a binary tree can be serialized to a string and the string can be deserialized to a back to the original tree. So here is an example. Your input will be given like 1, 2, 3, null, null, 4, 5. So 1 being the root node, 2, 3 is the child of 1. Both the nulls are childs of 2. As you see, they don't have any child nodes. For 3, it is 4 and 5. So there are a couple of methods that we need to implement. One is a serialize method, which will take a node and it should give the string representation for the serialized tree. And the deserialize method, which will take a string and give you a tree node back, which should represent this tree over here. So we are going to check the solution, and before you look at my solution, as I always recommend, do give it a try yourself and see if you can come up with your own solution and then take a peek at my solution. So let's move over to the board and check out the solution. So I have taken the same tree that we have seen in the example, which has a root 1, then followed by 2 and 3, and 3 has 2 child, 4 and 5. So the input will be given to us in this format. So first we are going to look at the serialization process, and then we'll see the deserialization. If you see this tree, we'll be getting an input like this, and we need to come up with our own serialized format of the string. So how we are going to do this is basically we are going to first complete the tree. So this is the tree over here. So a few things are not shown over here. So let's put that into place first, and we will see how it looks. So 2 has a child, left child, which is null, right child, which is null. Same goes for 4 and 5. So this is what the tree actually looks like when we are going to serialize it. So how this process will go, let's understand this. What will be the serialized string? So this is the string that we are talking about. So first we have a 1, that is the root element over here. Then 1 has 2 childs, so the next 2 elements are the child of 1. So this is connected to left child and this is the right child. So it will have 2 and 3. So we are filling from left to right. Then we have 2 elements for 2's child. So let's mark it with a different color. So 2 has 2 more childs that comes over here and here. And what are they? They are nothing but null. Right. Then we have 2 more placeholders for 3's child. So 3 will have the first child over here and the second child over here. So the first child always implies the left child, okay? And the second one implies the right child. So 3 has 2 childs, that are 4 and 5. So the next 2 placeholder would be 4's left child and right child. What are they? They are basically nulls. One thing keep in mind, when we have nulls, we will not consider their child. So that's why we skip from 3 to 4 directly and not going by those ends. Okay. So we are done with 4. Then we have 5, and the 5 will have 2 childs. That is over here. So 5's left child and 5's right child. So they are also nothing but null. So we are done with 5, and then we have bunch of n. So we are not considering n. So we'll go over them, and this will be our output string. Right. So we are going to talk about a serialization function over here, and we'll see how it will be depicted in the tree form as well. So what we are going to do is we are going to come up with the algorithm now. So we are going to create a method called serialize, and which will take a node. Okay, so if you look carefully at the problem statement, what you will see is that the value is represented by an integer. So we are free to use any character that we want, and we are going to use n, the one that we have used over here, to mark the null nodes. Okay, so the first step that we should do in the serialization function is to put that if node is null, then we are going to return the character n. Okay, so if it is null, so for all these nodes over here, all these nodes, we are going to return a n. Okay, And if you look at the serialization structure, what we do is we first print the node, means we first append the value to the node, and then we pass it on, right? So this is nothing but an array or a string separated by a comma. So what are we going to do over here is we are going to print the node dot val, so this is value of the node. Then we are going to put a comma, as we have seen here, that we need a separator, right, to identify if the number is 15. I don't know it's 1 5 or just a 15, right? So we need this delimiter to be a very important character. If we don't put this, it becomes a string like this, wherein I cannot make it out. So I need to put this delimiter character over here. That's why we are putting the delimiter over here. And then we are going to call the serialize method again. First is the left element, right? So we are putting the left first, and then we are putting the right in our serialized version of the string. So that's why we are going to put node dot left. So we are going to call the same function all over again with the left subtree, and we are going to call it with the right subtree. So let's visualize this. So let me build the tree over here. Okay, so initially the node is pointing to 1, right? And what we are going to do over here, we are going to build our output string as well along with the tree visualization, so that we see what is going to happen. So what we are basically doing, we are first putting the node dot val and then calling the serialization. So what we are putting over here is a 1 followed by a comma, and then we are going to the next level of the recursion. So we are going to the left. So if you see our algorithm, we have the left serialization first followed by the right serialization, right? So I hope you can see here. Okay, so when I call the left one, what happens is we are calling with 2. So the function will get called here. So it will be the node value is 2 now. So when we get a 2, what we do, first we check is it null? It is not null. So we are going to append the value to the string and put a comma. So we are going to put a 2 over here and then put a comma, right? Then again from that function, what we are going to do is we are going to call the same function again with the 2's left child, right? And that is a null. And what happens when we put a null back? So basically when we put a null back, we put a n, right? So one small mistake over here, it should be n comma, because we need the delimiter here as well. So what happens over here, we put a n and we put a comma, right? So the string becomes like this. But if it is null, we are returning, we are no more going into recursion. So what happens is we come back to the node 2 again. So the recursion ends over here for this subtree, and we return back from this position, right? And now we consider the right subtree of 2, which is again a null. So we get a null over here, and as we have seen that when we get a null, what we do is we put a n comma, going by this statement in yellow over here. So we are also returning from this subtree. So now both left and right of 2 is done, and we go back to the node 1, wherein we have processed only the left subtree. Now it's the time we should process the right subtree. So we call the right. So now this method is getting called for the node 1, right? Okay, so what happens is we call it with the value 3. So as soon as we get a value of 3, what do? We print the 3 and we go into the left recursion, right? So we are going to spawn a tree from this position, and we are going to call the node with the value 4. So as soon as we get a value 4, we print the value. So we put a 4 over here, and we call the left subtree once again from 4. So we call the node with a null. So when I get a null, what I do, I print a n over here, and there is no further possible ways from null. So we come back and we call the right subtree from 4, which is also a null, and we print n immediately and we return back. So let me make some space over here. Okay, so we are done with 4. So the next is 3's right, which is a 5. So the node will be called with 5. And as soon as I get a 5, what I do is first I print the value of the node, that is 5, and I go to the left recursion. So in the left recursion, again I get a node which is null. So we return back and we print the value n over here. And then we go to the right subtree over here, which is also a null. So we return back from this as well, and we put back a null over here again. So you can see here that this and this is now completely identical, and we have come up with the serialized form of this tree. And we have to take this string and we have to deserialize and construct a tree back from this, right? So let's see how we can deserialize this and come up with the solution. Let's put down our algorithm over here. This deserialize gets a string s, right? Unlike the serialization which received a node, the deserialization will receive a string s, and we are going to use the string s to come up with the tree node, and we are going to reconstruct this entire tree that we have seen over here node. So first what we are going to do to split s by our delimiter, right? So what will happen in this case, we'll be splitting by the character comma over here, right? So what will give me is a bunch of tokens over here. So let's call it as t. So what are those tokens? Those tokens are nothing but each element without the comma. So we are splitting by the comma, so we will get all these tokens. Okay, so our t is nothing but an array containing these tokens. Now what we are going to do is we are going to construct a queue, and we are going to put everything that we got inside the queue. We all know the queue is a data structure wherein the first element to get inside is the first element to come out. So it's basically a FIFO data structure, right? And it's queue. So what happens in a queue is from one end we queue things, and from the other end what we do is we dequeue things. So if you see, what we did is basically we add all the tokens to a queue. So we have added all the tokens, and since we have all these tokens, so you can see that the head is at the beginning, right? At the beginning of the queue. So what we are going to do now is we are going to call a different function, which will be a recursive function, and which will help us to build this entire tree from this queue. So let's say the name of the function is build tree. And we are going to pass the queue that we have to this function. So now let's see how this function will look like. So let's say this is my build tree function, and which is going to take this queue that we have, right? So now what we are going to do in this function is we are going to do a queue.poll, and we will get an element once we do a queue.poll. Queue.poll will give me a value which is an integer. So what I'm going to do is I am going to create a node. I'm going to create a new node using this value e, right? Now the thing is that we have a node 1, but we have not said it's left or right. It's left and right is now dangling. So there is just a node sitting over here which is 1, which doesn't have a left and the right? So our node is now ready, but the only problem with this node is we don't have the left and right set to the node. We still don't know what we are going to put in the left and the right. If we just call the build tree function again over here with the queue that I have, and let's suppose that this returns back a node, right? So what will happen in this case is if I do something like this for the left subtree, get a value 2. So it's going to poll again and get a value 2, right? And it will further go ahead and try to build its left subtree. So it is going to call the same function again with a null, and it will try to build its left subtree, right? So here it is essential for us, that's why I have left a space that equals n. In that case, what should we do? We should return a null. Now just see, we are returning from the statement, right? So what will happen is we are not trying to set the left and right for the null, right? So what is going to happen in this case is we are going to return a null to it. So how this null will be treated in this function? So 2 is going to set its left as a null, right? That's what the statement say over here. We are assigning node.left for the 2, right? And it sent me back a null, right? So this part is done. Now the second part is that we can do the similar thing over here as well. Then we can just call the build tree function with the nodes remaining. So just to visualize over here, 2 is done and this null is popped out. 3 element has been popped out so far, right? And this is the link that has been established. So this is all present on the call stack, right? So the same thing will happen as well for this guy. So what will happen is it will call the function with the queue, and what it will get is a null. and we are assigning this null to the right subtree of 2. That's what has happened. So this 2 function has been completed for 2. So what will happen is now 2's left and right is done. Now 2 will, now 1, this element 1 has invoked the call on its left subtree, right? So what will happen is it is going to return this node at the end, right? So at the end, what we should be doing is we'll be returning this node that we have created. For normal case, for null cases, we have already handled it over here. For the other cases, we are returning the node. So for 1, what will happen is it will return the node 2, right? And which it will assign to its left, right? So you can see that our tree is slowly getting constructed. So this null has also been popped out, right? So so 2 is done. So for 1, left is done. Now it will go for the right one. So it will call the same function again, and this time it will pop out a 3, right? So we'll get a 3 over here, and 3 will try to set its left child again. So it will call the same function. So 3 is popped out, so it will be called with a 4 over here, right? Because the next element that is on the queue is a 4. Okay, so 4 will try to set its left child. What it will get is a null. It will set a null. Then 4 will try, so 4 is done, this null is done. So again 4 will try to set its right child. So it will call again and it will set a null. It will pop out a null. So 4 is also done. So now 3 will try to create its right child and it will pass the queue. So what it will pop out is a 5. So the 5 will come over here, and then 5 will try to set its left child. It will pop out the next element and set it there as null. Then a 5 will try to set out its right child. It will also get a null and it will pop it out. So now what will happen is now 5 will return. So 3's right will get a 5 as a node to its right. So the entire tree will look like this. And if we remove the null from this tree, what will happen is the tree will look something like this, which is nothing but the actual tree that we have received as an input 1, 2, 3, 4, and 5. So this is how the entire algorithm works, and this is how we are going to serialize and deserialize the tree, and we are going to see in the code how the solution looks. So we'll head over to Leetcode and we'll quickly look at the code. So initially what we have is a serialize method, and the serialize method is very simple. We talked about if our root is going to be null, in that case what we are going to do was we are going to return a n followed by a comma, right? And if so, this is this part of the algorithm that we are talking about. So if it is null, we are going to return, otherwise we are going to take the value and go into the recursion. So we are going to return the value name was root.val, plus we are going to append a comma, and we are going to call the serialize function again, and we are going to call first with the left and then with the right. So this is what the entire serialization looks like, and we are going to do the deserialization part also very quickly. So this is just a simple 3 lines of code, nothing else, and this 3 lines of code will produce this string that you see over here, right? So now we are going to look at the deserialization part as well. So what we are going to do basically is first we are going to, so we are passed with the data and we need to split this data based on the delimiter that we have used. So it has to be the same delimiter that we have used over here, right? So what this delimiter is going to do is it's going to give me a bunch of tokens. So let's call it tokens. So we have a list of array of tokens over here. And the next thing that we are going to do is we are going to build a queue which will contain string, and let's call this queue only, and it will be a linked list implementation. So this queue is I am going to add all the elements into this, all the elements that we have got as a token into this. So what we need is a list over here. So arrays as list I'll do and pass on the tokens. So what will happen after this statement is our queue will be populated like this, somewhat like this. So we'll have all the elements in the queue added. So the next thing that we are going to do is we are going to return the build tree function from here. And this build tree is going to take our queue and it's going to return me a tree node, right? Because we are returning a tree node. Let's say we have a private method which returns me the tree node and the name is build tree, and which is going to take a queue of string and let's call it queue. So what we are going to do is like we are going to get the element out of the queue, so we are going to do a queue.poll. So once we do a queue.poll, the first thing that we should check is n means the null delimiter or not. So we are doing a equals ignore case, but you can use a equals as well, because we know that it's going to be capital L N all the time. And if it is so, we are going to return a null from here. Because if not, then what we are going to do is we are going to construct a tree node. Let's call it node, and let's see, they have a constructor with the value, so let's leverage that. So we are going to pass element, but to remember, element is a string and we need to pass it as a integer. So we are going to do a integer.parseInt, and we are going to take this element. So our node is ready. Now we need to set the left of this node before we return this node back. So we are going to call build tree again with the same queue, and we are going to call the right subtree as well with. So we are going to pass both this, and once we are done, we are going to pass this node back, right? So this will return the entire tree, and this will return back the tree to the calling function. So let's run this code and see. I'm sure that I have made some here and there. Okay, it will be element, not e. So let's run it again. Well, you can see that it has been accepted. Okay, so our solution has been accepted, and this is the whole algorithm that I wanted to pass on, that how a simple approach that can help us build this solution. So do let me know what you think about this video. If you think this video was helpful, do give it a like and do share as well. And if you haven't subscribed, please feel free to subscribe to the channel and help the channel as well. So one more thing that I wanted to mention over here is, like, if you want me to solve any particular problem, then do drop a comment with the Leetcode or any platform or any particular problem that you have in mind, which does not belong to any platform either, and I can definitely try to solve it and create a detailed video on the same, like the one that you are seeing now. So I hope this video was helpful. Do let me know in the comments. Do give it a like if you think this solution was worth giving a like. And yeah, that's all from this video, and thank you once again. Have a great day.